Welcome to another physics class. During our previous lesson, we talked lengthily on the equation of linear motion, in which we gave various examples. So today, we are going to another topic, which is uniform circular motion. When you say uniform circular motion, according to the statement, is the motion of an object in a circular path, which is moved with a constant speed. That is, uniform circular motion is motion of a body moving in a circular path with constant speed. Motion of a body moving in a circular path with constant speed. That's what meant by uniform circular motion. Now, what are the characteristics of uniform circular motion? Character of uniform circular. One, it is being characterized by constant speed. That is, the body will be moving with constant speed. But as it's moving with constant speed, moving with constant speed, but velocity is continuously changing. It moves with constant speed, but the velocity will continuously change. That one will not lead us to number 2. It has varying or variable velocity. Once it has variable velocity, the variable velocity, which is due to changing in direction. Due to changing in direction. So it has variable velocity. 3. Once the velocity is variable, then the acceleration is directed toward the central part and is not equal to 0. 4. The velocity is tangential to the circle and perpendicular to the radius of the circle. And number 5, characteristic 5. There are forces. There are two forces. That keep the body to move constant speed. There are 5 possible characteristics of a uniform circular motion. As I said, 1, it will move with constant speed, or as it's moving with constant speed, the velocity will be continually changing. 2, it has a variable velocity due to changing in direction. 3, the acceleration is directed toward a fixed point or toward the central part and is not equal 0, unlike the case of linear motion. 4, the velocity is tangential to the circle and perpendicular to the radius of the circle. And number 5, there are 2 forces that keep the body to move with constant speed. That is, consider the circle below. Let's say an object is circling through this circle. This is the radius r. When it's moved like this, then this is the direction of the motion. This is the radius, that is the distance from the circular path. So since there will be change in direction like this, as I said, this is delta v, that is change in velocity, and as I said, this velocity, according to number 3, is tangential to the circle and perpendicular to the radius of the circle at any particular point. So if you take it from this place, this is another r. This one, the velocity is tangential and perpendicular to the radius of the circular path. Take another one, it will be like this. This is delta v. Take another radius like this. That's how, since there is always change in velocity, then we say the acceleration cannot be equal to 0. Although, due to this, the 2 forces that will keep it to the center, it will be moving with constant speed, but velocity will be changing. Acceleration will not be equal to 0. And as I said, the acceleration is directed toward a fixed point, which is toward the center. That is how, so delta v now is equal to change in velocity. And the change in velocity is due to change in direction as it's moving through the circular path. As I said here, under the point number 5, that there are 2 forces that keep the body toward the center. The 2 forces are centripetal force and centrifugal force. But the first thing we are going to look at now is centripetal centripetal, or you can call it radian, or you can call it angular acceleration, centripetal, or radian, or angular acceleration. And when you say angular acceleration, under this one, the symbol is A subscript C. When you say angular acceleration, or centripetal, or radian acceleration, is the acceleration of a body moving in circular path, which is directed toward a fixed point, toward a fixed point, toward a fixed point, or toward the central part of the motion. That is centripetal acceleration. And the magnitude of radian acceleration is given as AC is equal to V squared over R. AC is equal to V squared over R. Already we know that our AC is radian acceleration, where V is equal to speed or velocity, and R distance from the central part, or you call it radius. Distance from the central part, or radius. Now, let's look at examples of uniform circular motion. 1. Rotation of the earth. Rotation of the earth about its axis. That's number 1. When the earth rotates, it's a typical example of circular motion. As I said the other time, the earth will rotate with constant speed due to the effect of centripetal and centrifugal force. We are still coming to that later. 2. An electron revolves round the atomic nucleus. This according to the chemistry. When an electron revolves round the atomic nucleus, that is, let's say, for instance, you have sodium as an element, 11, as atomic number. When you draw the electronic shell, the inner shell, you take just two electrons. This is the nucleus. The particle present in the nucleus, the electron will revolve around the nucleus. So when the inner cell, which is K cell, receive two electrons, which is its maximum, the electron will jump to the next cell, which is L cell, and the L cell will take 8 electrons. And the last cell, which is M cell for sodium, will just take 1 electron. So the revolving of an electron around the cell now is a typical example of uniform circular motion. When a cell is being completely free, the electron will jump to the next one, depending on the atomic number of that element. Number 3 example, airplane changing direction. When airplane change direction, definitely that the changing direction of any airplane is a typical example of circular motion. Another one, number 4. Another one, motion of planet round the sun. When any planet moves around the sun, it's a typical example of uniform circular motion. Number 5. An athlete running around a curved track. An athlete running around a curved track. Another example. Number 6, a point on the circumference of a rotating wheel. This is to state but few. We have many examples of uniform circular motion in practice. But let's talk on this number 6 for now. Next is centripetal and centrifugal forces. As I said the other time, that for a body to move constantly in a circular path, there are 2 forces that must act on it. And when the effect of the 2 forces are balanced, then the body will be able to move with a constant speed. So the first force is centripetal force. Centripetal force. This one is an inward force. Inward force that keep a body moving in a circular path, keep a body moving in a circular path in constant speed. That is the inward force that will keep that object constant to move in a constant speed, what we call centripetal force. And the other force, which is centrifugal force. This one is the outward force that keep the body moving in a circular path in constant speed. Now let's see the effect of the two forces with this diagram. This is the center of the motion. When there's a body moving in this circular path, the inward force that will pull this object toward the center is what we call centripetal force. And there must be another one, push the body outward from the center by this arrow now. This one will be centripetal force, that is the inward force, while the second one, the outward, will be centrifugal force. So when the effect of these two forces are balanced, then the object will now move with constant speed in the circular path. So that's the illustration of the two forces. So from here to here now is the radius of the circular path. So the inward force, centripetal force, the outward, centrifugal. The magnitude of both centripetal and centrifugal forces is given as Fc, that is either centripetal or centrifugal force, is equal to MEC. Don't forget the other time, our AC is centripetal acceleration. Therefore, we can now say F is equal to V squared over R. So where our Fc will be either centripetal or centrifugal, because they have the same magnitude, and where M is equal to mass of the body moving in the circular path, V speed or velocity of the body moving in the circular path, and R radius of the circular path. Now, from what we have written on the board now, we can now see that the magnitude of centripetal and centrifugal force depend on three factors. Number one, the mass of the body. cycling the cycle. 2. Velocity at which the body is moving. And 3. The distance from the central part. Don't forget that the magnitude of centripetal and centrifugal force depend on 3 factors. 1. Mass of the body. 2. Velocity or speed of the body. And 3. The radius or the distance of the body from the central part. The next thing we are going to look at is angular speed or angular velocity. The symbol is called omega. And when you say angular speed or angular velocity is the ratio of angle turns through to time taken by a body moving in a circular path. That is, from the definition, we can now say omega, which is the angular speed of velocity, equal to theta over t, where this omega is equal to angular speed of velocity. Theta is angle turn through, and t is time taken by the body to cover a certain distance. Now, the unit of angular speed of velocity is radian per second. It is rad per second. That's the unit of angular speed or angular velocity. Since this one is angular, it's different from linear motion. If it is linear motion, the unit of either speed or velocity under linear motion is meter per second. But this one is dealing with angle, so it's radian per second or rad per second. Or in another way, angular speed or velocity is the ratio of linear speed to the radius of the circular path. Say the ratio of linear speed v to the radius r of the circular path. That is the omega equal to v over r. Don't forget, our omega is angular speed or velocity, where this one is linear speed and r is the distance from the central part of the radius of the circle. V is equal to linear speed, r is radius of circular path. Now, the next thing is we want to look at the relation between the angular speed or angular velocity, linear speed, and the distance or radius of the circular path. That is how we will arrive at this omega is equal to V over R. This is what we want to look at now. Now say from the circle below, this is the circle. Let's say an object. This is the center of the object. This object move a, this is radius. Let's say it moved from here to here. This is another radius. Now, the distance covered here, from here to here, let's call it x. From here to here, and this is angle turned through, while this one is the radius. Now, from what I've done on the board now, the object starts from this point and stop at this point. It covers a distance x. Now say x is distance cover. Now, from mathematics, you can now say that this distance cover as indicated in mathematics is termed, the s in mathematics is termed as length of an arc. And according to this thing, that is it means this circle now, this plane form a sector, and the area bounded by that sector by this place is length of an arc. So, mathematical length of an arc, the formula is theta over 360 multiplied by 2 pi r. Theta over 360 multiplied by 2 pi r. And under this one, note the pi is taken in radian. The unit is radian. And pi radian is equivalent to 180 degrees. If that is the case, if we have 2 pi rad, then it will be equal to 360 degrees. If 2 pi rad is 360 degrees, then we can now say that this term will cancel this one. Then we are now left with our s, which is the distance covered by that body, is equal to theta r. Now make theta the subject of the formula. Theta now will be equal to s over r. That's the magnitude of the theta. That is the distance covered over the radius of the circular path. Note that that's a formula. When we get to calculation, we are going to apply it. Now, you can now see that, but we said the other time that our omega is equal to theta over t. If that is the case, Let's substitute for the value of theta now by removing theta and put S over R. So we are going to have omega is equal to S, that is theta, over R, then divided by T. If that is the case, we are going to have S over R multiplied by 1 over T. So from there now, we can now say omega is equal to S over RT, S over RT, which is equivalent to 1 over R multiplied by ST. Don't forget, our S is distance, our T is time taken. Now, our S is distance, our T is time taken. You can now say from linear motion, the quantity that has distance over time is, from linear motion, S over T. S over T is equal to V. What is V? That is linear velocity. If that is the case, remove S over T, put V. We are going to have omega is equal to 1 over R multiplied by V. So we are going to have omega is equal to V over R, or V is equal to omega R. That is the connection or the relationship between the linear speed, angular speed, and the radius of the circular path. You can now say where V is equal to linear speed, omega is equal to angular speed or velocity, R is distance from the central part or radius of the circular path. Next is types of centripetal force. 1. We have tension, centripetal force. This one is the centripetal force, is the centripetal force. Acting on a string or rope. String, rope, or cord, keeping a body moving in circular path with constant speed. That is, when you extend a string or rope or cord, maybe you attach a load on it, and while it runs, the type of centripetal force that works on it is called tension. Number 2, one is gravitational centripetal force. This one is the centripetal force that acts on a planet keeps keep it move round the sun with constant speed. 3, which is electrostatic centripetal force. This one is the centripetal force, that keeps an electrons round its cell, round the cell in a constant speed. So these are the 3 types of centripetal force we have. Now, today we come across the following formula. We come across the following formula. 1, we have our radial acceleration or centripetal acceleration. Radial acceleration as AC is equal to V square over R. 2, centripetal or call it centrifugal force as Fc equal to MAC, or Fc is equal to mv square over R. Number 3, we come across angular speed or velocity as omega is equal to theta over t. At the same time, number 4, we have our angle. We call it angular distance. Theta. We have theta as S over R. And number 5, at the same time, we have our linear speed V as V is equal to omega R. So today in our discussion, we've come across all these formula. And don't forget what each notation stood for. For instance, like AC, you don't want to repeat ourselves. Centripetal acceleration or radial acceleration. V is velocity. R is radius of the circular path or distance. M is mass of the body in a circular path, where Fc is centripetal centrifugal force. This one is angular speed or velocity, where theta is angle turned through, t is time taken. So these are the formula we've come across today. And in our lesson, we are going to apply all these formula to solve problem. And as I always say, if you are new to this channel, please don't forget to like, share, and subscribe. So when I upload a new video like this, you will be able to get the notification in time. Till when we meet in our next lesson, thank you.